this laboratory exercise, we are going to program a blinking LED through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, LED red color, 330 ohms resistor, breadboard, connecting wires, and computer with Arduino software. I started by assembling the hardware. Placing the 330 ohm resistor on the breadboard and connecting the LED pin to one end of the resistor and the other end with a connecting wire to the digital pin 13. Next, the other end of the LED connects to the other wire. The other end of the black wire goes to the G&D pin of the Arduino. The Arduino hardware is connected to the Arduino software using a USB cable from the hardware to the computer with the software. Then, I inputted the code in the Arduino IDE. After the code was done, I uploaded it to the Arduino hardware. To create a successfully programmed blinking LED through Arduino. In this laboratory exercise, we will program an LED with push-button switches using digital inputs through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, LED red color, 330 ohms resistor and 10K ohm resistors, push button switches, breadboard, connecting wires, and a computer with Arduino software. I first assembled the hardware. Place the two button switches on the breadboard beside each other. Connect one leg of the 10K ohm resistor to one pair of legs of the push button, other pair of legs of the push button to the common ground. Do the same for the other push button. Connect the other leg of the 10K ohm resistor to the common 5V line from the Arduino 5V pin. Connect the positive terminal of the LED to the 330 ohm resistor. The other leg of the LED is connected to the common GND line from the Arduino's GND pin. The other end of the 330 ohm goes to the Arduino digital pin 3. Finally, connect the push button's output pins to digital pin 8 and 9 of the Arduino Uno. Then, I connected the Arduino hardware to the Arduino software using a USB cable. Then, I inputted the code in the Arduino IDE. After the code was done, I uploaded it to the hardware. After uploading the code, the LED is off. Press the left button to turn it on and the right button to turn it off. In this laboratory exercise, we are going to program an RGB LED light circuit through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, RGB LED, 330 ohms resistors, breadboard, connecting wires, and computer with Arduino software. I first assembled the hardware. I first placed the 3 resistors on the breadboard, which will be connected to the 3 pins of the RGB LED. To the unconnected leads of these resistors, using colored wires, connected them to the following manner. The LED with the flat edge of the RGB LED should be connected to the digital pin 11, the third lead to the digital pin 10, and the last lead to the digital pin 9. Then, the common cathode pin of the RGB LED is connected to the GND of the Arduino board using a black connecting wire. Then I connected the Arduino hardware to the software using a USB cable from the hardware to the laptop with the Arduino software. Next, I inputted the code in the Arduino IDE with the application of analog signal and PWM. After inputting the code, I uploaded it to the hardware. The board will automatically run the code and create a successfully programmed RGB LED circuit. In this laboratory exercise, we are going to program a potentiometer using analog input through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, potentiometer with 10K ohms, breadboard, connecting wires, and computer with Arduino software. I first assembled the hardware, placing the potentiometer on the breadboard. Using colored wires, connect the center lead of the potentiometer to the A0 pin of the Arduino board. Connect one unconnected leg of the potentiometer to the 5V pin, while the other leg to the G and D pin of the Arduino. Then, I connected the Arduino hardware to the Arduino software using a USB cable from the hardware to the computer with the Arduino software. Then, I inputted the code in the Arduino IDE. After the code was done, I uploaded it to the Arduino hardware. After the code is successfully uploaded, the serial monitor gives an output from 0 as the minimum and 1010 as the maximum value. These two values are obtained by rotating the knob fully counterclockwise and clockwise respectively. In this laboratory exercise, we will program a light sensor, an application of LDR, through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, LDR photocell, LED red color, 330 ohms resistor, 10K ohms resistor, breadboard, connecting wires, and computer with Arduino software. First, I assembled the hardware. Using a black wire, connect one leg of the LED to the common ground. Connect the anode of the LED to the 330 ohm resistor, while the other lead of the pin of the 330 resistor goes to the digital pin 12 of the Arduino Uno. Using another black wire, connect the unconnected lead of the LDR to the common GND pin from the Arduino Uno. Connect one leg of the 10K ohm resistor to the common 5V source for the pin of the Arduino, while the other lead connects to the one leg of light-dependent resistor. Within the same whole line, a wire is connected to the analog pin A0 of the Arduino Uno. The Arduino hardware is connected to the Arduino software using a USB cable port from the hardware to the computer with the software. Next, I inputted the code in the Arduino IDE. After the code is done, I uploaded it to the hardware. When the LDR is exposed to a good amount of light source, the LED light is off. Covering the LDR light sensor or turning off the light of the room, the LED turns on. In this laboratory exercise, we will program a piezo speaker to create sounds and tones through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, piezo speaker, breadboard, connecting wires, and computer with Arduino software. I first assembled the hardware, placed the piezo speaker on the breadboard, connected a green wire to the positive pin of the buzzer and a black wire to the negative pin of the buzzer. The black wire is connected to the GND pin of the Arduino, and the green wire is connected to the digital pin 8 of the Arduino Uno. Then, I connected the Arduino hardware to the Arduino software using a USB cable from the hardware to the computer with Arduino software. Next, I inputted the code in the Arduino IDE. After the code was done, I uploaded it to the hardware. The program starts to play the tones that we put in the tones array. 10 tones will be played simultaneously with a 1-second delay after the last one. The program plays back the first tone after the last tone. In this laboratory exercise, we are going to program a temperature sensor through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, LM35 temperature sensor, breadboard, connecting wires, and computer with Arduino software. First, I assembled the hardware. I placed the LM35 temperature sensor on the breadboard. Connect the positive 5V pin of the LM35 to the positive 5V pin of the Arduino using red wire. GND pin using the black wire to the GND in the Arduino. Out pin using green wire to the analog pin A0. Then, using a USB cable, I connected the Arduino hardware to the Arduino software from the computer. Then, I inputted the code in the Arduino IDE. After the code was done, I uploaded it to the hardware. You should see the values of the temperature in degrees Celsius print out in the serial monitor. In this laboratory, we are going to program a servo motor through Arduino Uno. The materials needed are Arduino Uno R3, USB cable, servo motor SG90 micro, breadboard, connecting wires, and computer with Arduino software. I first assembled the hardware, connecting the connecting wires to the ports of the servo motor, the red to the red, the brown to the black, and the orange to the orange. Then, I connected the connecting wires to the Arduino Uno R3. The red to the 5 volts, the orange to the digital pin 9, and the black to the GND pin. Then, I connected the Arduino hardware to the computer with the Arduino software using a USB cable. In order for the code from the software be uploaded to the hardware. Then, I inputted the code in the Arduino IDE. After the code was done, I uploaded it to the Arduino hardware to make a successful and running programmed servo motor.